Yep, I am a free agent employee. I'm called Max, and I want to talk about a personal project I've been working on for a little while called Ruby RPG. So I think that Ruby's a little bit more than Rails. It's a great language, and the reason I think it's a great language, well, here's a quote from rubylang.org. But for me, I find it quite nice and easy to write very readable Ruby code, something which I've not found in other languages like JavaScript. Its flexibility means if I run into a problem, I can pretty much always solve it in Ruby. It's got a great type system, but you can bend and break the rules as you need. And it's also really testable. We've got a great culture of TDD when we work with Ruby, and that means we can release with confidence. We know what we've broken most of the time, which makes it a really fun language to work with. And controversially, it's actually quite fast right out the box. You don't necessarily need to be running one of the fancy Rubies. CRuby is great. So this makes Rails fantastic. But these qualities are also exactly what we need for game development. Why game development? So in game development, iteration is king. If you can come up with ideas and go through them one after another, trying things out, seeing what works, what doesn't, what feels good, what doesn't feel good, and you can iterate on those ideas, you're going to make something great. Game development's historically had a bit of a problem with testing, rooms of QAs being asked to jump in a corner to see if they're going to fall through the floor. Well, if we bring on Ruby's approach to TDD into the game dev space, maybe we can make some inroads into making that better. And game development should be fun. You should be enjoying what you do. If you enjoy what you do, it's going to shine through in your in the art you make. So I've built Ruby RPG. This is an open source Ruby-based game engine. Here's a screenshot from it that you can go and have a play around with later. So I've used this term game engine a couple of times now. So what is a game engine? Well, a game engine is to games what Rails is to web apps, or perhaps what websites and browsers have in common. So you've got all of these different concerns when you make a game. You've got a whole stack of artwork. It might be images, animations, models, visual effects, loads of stuff. You've got a whole load of behavior you want to implement, the rules of the game. When I press this button, what happens? There's huge numbers of things you need to keep in mind. And the game engine sits underneath it all, tying it all together, bringing things onto the screen, and bringing it into the hands of the users. So, how does the architecture of Ruby RPG work? In Rails, we have MVC, but in Ruby RPG, we've got something called the entity component system. If you've ever had to play around with Unity, this will be quite familiar to you. But I've implemented it in Ruby. So the idea is we have a whole load of objects in our game. They could be trees, they could be pieces of the ground, they could be your player. Anything you can think of is going to be an object. These are our entities. They have positions, rotations, and scales. That's the model matrix. That's what that's called. So we can place things in our world, and you can have children. So there's a whole hierarchy going on here. Object A has object B as a child, has object C as a child. And when you move a parent, the children move too. And you can solve a whole host of problems like this. Suppose you've got a car driving along and you want someone to be sat in that car. They want to stick with the car. You don't want to have to write code to keep them up moving along with the car. You just use parenting. You can also destroy game objects, and then all the children get destroyed. That's a really good way of sort of cleaning up after yourself. Just stick a parent on and get rid of everything. But perhaps the really important thing is the components. So game objects can have many components, and these components are scripts that you write your behaviors in. So these might be things like character controllers, or things to render it to the screen, or maybe it's a light or a camera. The sky's the limit. I provided a whole load of components, but you will be writing a lot yourself. That's where the bread and butter of your programming is going to go in when you make games. So components have a couple of lifecycle hooks. They've got a start for when they're added onto a game object, They've got an update, which takes the time that the frame took, so you can do animations and things and decide what's happening based on the keyboard, stuff like that. And there's a destroy function, so when it gets destroyed, you can run a little bit of code. So maybe you make an explosion effect or something, these sorts of things. So what sort of components have I built for you to use? So I've tried to do all the really complicated stuff. So to start with, there's two different kinds of cameras. Perspective cameras, which are a camera where things in the distance get a bit smaller. A camera's to look into the world, so it actually ends up on the screen. An orthographic camera as well, which is really good for 2D games or sort of side scrollers or things like that, where you don't want perspective to get in the way. I've also added a couple of lights, so point lights, so you can illuminate an area of your scene, and a directional light, so you can do sort of ambient lighting. Give your game some nice feel. And then come the renderers. So there's lots of different things you're going to want to render, but most commonly it's going to be meshes. So the mesh renderer takes OBJ files, which is quite a common file format for objects that you might produce in a program like Blender or Cinema 4D or something like that, Maya. Your artist's probably going to give you a whole load of those, or if you're handy with those tools, you'll make some yourself. And it can render those to the screen and use the positions of the game objects to make sure that they're in the right place and decorate them with the right textures and all that. There's also sprite renderers. These are sort of 2D flat things. You can use them for making 2D games, like maybe Space Invaders or something. Or you can use them in the 3D context to sort of put a picture on a wall or a spray or something. There's also text rendering. So if you've got like a signpost, you might want to put dynamic text onto it. And there's the UI versions of these 2D ones as well. So you can have a UI up on your screen. So you can say, oh, this player's got this much health or whatever it happens to be. So that's the inbuilt stuff. Oh, and there's a basic physics engine that I've built. It's still a bit of a work in progress. Physics engines are hard. But you'll be writing most of them because your game logic is going to be very specific to what you want. So let's have a little look at what building a game in Ruby RPG might look like. First off, we're going to start up the engine. We provide the base path because there's dynamic loading going on. And we also provide a block. This block is really important. It's the first thing we're going to do in the game. We'll use this for setting up our scene, making sure there's stuff in our game. That gets you going. That really bootstraps you. So you're going to want to put lots of stuff in there. Specifically, you're going to want to start with a camera. So this is how you make a game object. You just new up a game object. You put it in a sensible place using the position, and there's also rotation and scale, but they're optional. And you can provide it some components. So in this case, we've provided the orthographic camera, given it some sensible width and height and the depth that it can see to. And we're going to add a little player to the scene. This is a ship. Maybe you can see where this is going. We will also put that in a sensible place and add various components to that, like the ship engine for steering around. We're going to give it a gun for shooting down some stuff, and we're going to use the important sprite renderer. So we'll load in a PNG, which we've got on our disk in our assets folder, and we'll let it render. We'll also put some asteroids around. I think you can really see where this is going now. I've just wrapped up the call to create the game objects in this one, but you get the idea. So let's pop the hood on that ship engine. The update loop looks really simple. It's just every single frame, we're going to change our speed based on what the user's doing on their keyboard. If they're trying to accelerate, we'll add that to the speed. If they're trying to decelerate, we'll back off a bit. The speed is stored as a sort of global vector, which means we can sort of move around and have that nice drifting effect as the ship flies around. And we'll do a similar thing with the rotation, so we've got a torque there. And a few components later, and we've got a game of asteroids. All right, I'll just let that play because I quite like the animations. All right. So let's talk a bit about testing. I did mention this earlier. So it's really important to be able to test your stuff because you're going to be making changes really rapid fire. Every single one of those constants, you're going to be chopping and changing every 2 seconds, reloading the game. Did I break anything? Who knows? So we're going to write some tests once we're happy. We're all pretty familiar with unit tests. This will just be sort of, does this thing work in isolation? And similarly, integration tests, they're a little bit up the testing triangle because we're going to get a couple of game objects together or maybe a couple of components and see what happens when we use them together. But what I want to talk about right now is the top of the triangle where we've got some snapshot tests. So I've built something similar to Capybara where we can launch the engine and we can have sort of like this test object in there. So we can do things at various frames. Like in this case, we set up a teapot and add a little light and a camera, point them at one another, take a screenshot, and then we can check that screenshot into our version control and compare it against what comes out. If we ever mess up that light, or if we ever mess up the way the rendering's happening, we're going to get told with a red test. So this is what will come out of that. This is what happens when I run it. We get one of these, and if I was to mess with the light, this is what a failing test looks like. It says, oh no, your test failed. This is what went wrong. You don't want many of these. They take quite a long time to compare pixel for pixel, but they're really powerful. All right, so I'm just going to dip my toe into explaining how rendering works. So we're using OpenGL here. There are lots of other graphics APIs, but OpenGL's got some nice Ruby bindings with a Ruby gem, which I've used. The idea is that the mesh renderer component is actually just quite a thin facade. We, in front of something called the instance renderer, we're going to batch up all of our mesh renderers when they've got the same mesh and the same material. We don't want to be doing this whole process for every single object in the scene. If we've got 1,000 trees, we just want to do it once. We then upload the data for the meshes up into the GPU. There's functions for that in OpenGL. It's kind of convoluted, but yeah, we do that. We'll do the same with the textures. We'll upload those. That happens as a sort of thing when you new up a texture. And there's also something called shader code, which I've skirted around so far. This is a whole nother language called GLSL, provided by OpenGL. It's GL's shader language, which lets us decide what color each pixel wants to be. That's got to be compiled. So we're going to compile that and upload the result into the GPU. Other engines might compile ahead of time, but I just do it on the fly, it's fine. So that happens at the start, and then once we're running, all we have to do is gather up the batch data, say this one's in this position, this one's in this position, this one's in this position, draw them all please, and it does it. We can also modify various parameters in the material, so those can go in. So maybe we change the light slowly over time, like maybe the trees are withering or something. So we can write our custom shaders to take into account interesting things from our materials. And you get something pretty coming out the other end, like this. So thank you for listening to me talk about my game engine.